Welcome to homework.
In this question, we are asked to choose the solution with a greater pH. In the first case, we are given two different metal chlorides with the same concentrations. And in the second part of the question, we are told about two different metal nitrates with the same concentration. So to answer these questions, we have to know this theory that tells us that if a metal, let's say M, that has made a compound with the anion X with the charge -1. Let's say the metal had a N plus charge, and so the formula name would be MXN. And if we reacted this with water, it can dissolve in water and form hydrated complexes of the metal ion. So they are mostly hexa-aqua complexes. And this will also release the X minus anions, which are going to be neutralizing the charge of the hydration sphere. And the hexa-aqua complex produced in this way can act as an acid. And when it acts as an acid, it can undergo this reaction. H2O6 with the charge N plus can react with water and produce this complex in a reversible manner. So it will be a penta-aqua hydroxyl complex, where one of the water molecules would donate its hydrogen and form a hydroxyl group instead. So the net charge is going to be N-1 for that complex when we account for the charge coming from the hydroxyl group. And this reaction will also produce hydronium ions that are formed from the free water molecules that will accept a proton. And this being a reaction of a weak acid, it has a Ka value. So when we write the expression for the Ka value for this reaction, it will look like this. Ka is equal to the concentration of the penta-aqua hydroxy complex say N-1 first and then close the bracket to say concentration. And multiply the concentration of the penta-aqua complex with the concentration of the hydronium ions and divide this by the concentration of the hexa-aqua complex. So this is a M. Okay, and as we've discussed before, the concentration of the penta-aqua hydroxyl complex is equal to the concentration of the hydronium ions. And for that reason, we can omit this part and say the square of the hydronium ion concentration instead. So using this equation, we can calculate the hydronium ion concentration because we know this, which is the provided concentration for that metal ion, and the Ka value is something we can look up. So using that idea, we can solve for the hydronium ion concentration which will be equal to Ka times, let's say Ka times the concentration of the hexa aqua complex and take the square root of it. So we did this for 0.1 m nickel chloride and 0.1 m sodium chloride. We have to know that sodium chloride is not going to do this, and nickel chloride will do this and give a pH or a hydronium ion concentration of 3.2 times 10 to the negative 6, while sodium chloride will not do this, but the pH of a sodium chloride solution, a pure sodium chloride solution, has to be equal to 7 because it's neutral. Sodium chloride is made out of a strong acid reaction with a strong base, and if a strong acid reacts with a strong base to completely react with each other, where we don't have any more of the strong acid or the strong base remaining, which is the case here, we have a pH equal to 7. So for sodium chloride, the pH is equal to 7, and from the H plus ion concentration that we calculated for nickel chloride, we can calculate the pH for that, and that will be 5.49, or let's say 5.5. So we see that sodium chloride is what has the greater pH. Okay, and let's move on to the next part of the question, where we are asked to compare between tin nitrate and cobalt nitrate. If we had, sorry about that, this has to be a 2. If we had 0.1 m solutions of each. So we have to apply this idea to both metals, tin and cobalt, because both of them will form these hexa aqua complexes, unlike sodium chloride. So if we calculate the hydronium ion concentration for tin nitrate, we get this value 6.3 times 10 to the negative 3 m, and for cobalt nitrate, the hydronium ion concentration is equal to 4.5 times 10 to the negative 6 m. So we use this equation here to calculate the hydronium ion concentrations for tin and cobalt nitrates. And then we get these numbers, and we see that cobalt nitrate has a lower hydronium ion concentration, so it will have the greater pH value. So cobalt nitrate is the answer for the second part of the question.